Hello everyone, I am Prianka Mandal from William and Mary, and today I am going to talk about our work on understanding how IoT app security certification works in practice. Due to billion of potentially vulnerable IoT products in market, IoT product security is gaining attention from public sector. For example, FCC announced US Cyber Security Trust Mark for smart devices to help consumer make informed purchase decision and encourage manufacturers to meet higher cyber security standards. Considering this, there are many commercially licensed evaluation facility or certification lab that assess the IoT products and provide IoT security certification based on existing IoT security standards. For example, IOXT Alliance have their authorized labs and IoT security standards for certifying IoT products. While this IoT security certification itself is new, this process followed traditional security certification model. At first, IoT vendors pay for security assessment and the certification lab evaluate the IoT products and certify the products. And you may notice that the regulators and consumers are outside of this certification loop. Regulators only provide license to the certification lab, but that is based on some procedural factors like how many employees in their facilities or how their testing facilities are, but not that like their performance at finding vulnerabilities. And this kind of unvalidated approach might lead to the certified product that may have not been properly analyzed and may have vulnerabilities. So we ask this question, does this traditional security certification model work in the context of IoT product and as well as consumers expected it to? Now let's split this question, some more precise question. First, are the certified IoT products vulnerable? And if they are vulnerable, are they compliant or non-compliant? And finally, what consumers think about this compliance enforcement? And to answer this question, we performed several complementary studies. First, we analyzed a mobile IoT app and IoT security standards to learn more about the current status of the IoT security certification, and then we conducted a user study to learn about consumer perceptions. And overall, we have 17 exciting findings, and I am going to talk about each of these studies very briefly. So, firstly, mobile app analysis, and we found that at least 20 out of 30 certification lab assess mobile IoT apps, and because mobile IoT apps are the primary UI for controlling and configuring IoT devices. Therefore, we collected 11 certified mobile IoT apps from IOXT Alliance and analyzed them for finding cryptographic API misuse vulnerabilities, data leak vulnerabilities, and permission-related vulnerabilities. Here, I am only discussing about crypto API misuse analysis. In our analysis, we do not seek to coverage of all vulnerabilities. Rather, we focus on uncovering gaps in compliance enforcement. Therefore, we manually reverse engineer and analyze those certified apps for crypto API misuses and their implication. And overall, we found 35 vulnerabilities in 9 out of 11 apps. Now, let's talk about some of the interesting findings from our analysis. First, let me show you something interesting from one of the certified apps, and what do you see? It looks like they are using GCM mode with AES, and this is good, right? But if you look closely, there is actually something else going on. There are some string operation, and which results in using ECB mode with AES, and which is the worst possible mode for encryption. And we found that is the developer is using something vulnerable, but it looks like they are using something secure. And we found this in a certified app which is used over 5 million people. And there is also some other vulnerabilities that are expressed in their simplest form. Here, like using only AES without specifying any blockchaining mode. And this is also results like using ECB with AES. And the certification labs and like their tools they use, they should have catch this kind of simple vulnerabilities. And when we talk about the implication of these vulnerabilities, some certified mobile IoT apps using this kind of vulnerable encryption for transmitting audio and video data from IoT devices like baby monitors or cameras. And the automatic static analysis tools could not find this kind of vulnerabilities. While we do not expect them to find the evasive ones, but the tools could not find most of the vulnerabilities we found in our manual analysis. So we see that the certified app can have vulnerabilities. So, and does that make them compliant? In that case, like we answered this question, we performed a security compliance analysis with to see that whether the vulnerability in the certified products violate the relevant IoT security standards. We selected 5 popular IoT security standards and systematically extract the relevant part of the standards into a specific criteria and compare the criteria with the vulnerabilities we found in our mobile IoT app analysis. And in this analysis, we found something quite surprising. That is like, while vulnerability found in the certified apps explicitly covered by the standards, they would still be compliant. And we found that this can be happen due to 3 key reasons. First, the criteria can be overly broad. If you see the example that applications support currently generally accepted security and cryptography protocols and best practices, and this kind of broadness may help developer claim vulnerable code as compliant. Secondly, the test cases can be ambiguous. If you see the phrase excessive, how can we define excessive? Like how many extra permission is excessive, or what permission is unnecessary? And this kind of ambiguity is totally left for the tester. And finally, there can be loopholes in the criteria. If you see the phrase like using verified TLS where possible, and this kind of like a phrase gives flexibility to developers whether or not to use TLS. And we found that like this kind of flaws and ambiguities help developer to claim vulnerable product as compliant. Now let's see what user think about this compliance enforcement. To understand that, we conducted a user study with 173 IoT users. More specifically, we wanted to know what they believe about the compliance enforcement and who do they think is responsible for enforcing correct compliance standards, and who is responsible for who is liable for the vulnerabilities we found in the certified products. We recruited our participants from Prolific, and our survey consists of 39 multiple choice questions and pre-text questions, and we use thematic analysis to analyze the responses. So when we ask participants about their familiarity with IoT compliance standards and certification, most of the users were unaware of that. That is and this reason could be the early stage of adoption of the certification process, or the IoT vendors may not want to publicize it yet. As we found that only 2 of the 11 certified mobile IoT apps we analyzed disclose about the certification. And usually user focus on the brand reputation and product review while buying the IoT products, but most of our participants state that they will put their trust in the certification because they believe that certified products are more secure, and the developer spend more effort for the certified products. And next, participants believe that all the stakeholders, that is the developer, certification labs, and the standard bodies, All of them are responsible for enforcing correct compliance enforcement. But when it comes to take the liability, participants think that the developers are the most liable entity as they develop the app, so they need to ensure the safety and security of the user. Lastly, from our user study, we found that most users trust that this IoT security certification ensures more security in the products, while some still thinks that this certification is nothing but just red tape. Now let's get back to the question we asked at the beginning. What did we see? We can say that we definitely need this security certification model as it allows us to scale to certified millions of products while lab doing all the works. However, the unvalidated approach is clearly not working, as we found that the certified products can have vulnerabilities. So what is missing here is effective checks and balance to reform the model, that is for example developing tools for auditing certification labs effectiveness. And we also found that the vulnerability still exists even after the certification, and the current tools cannot detect those vulnerabilities. Therefore, we need effective and robust vulnerability discovery tools to help developers and certification labs during the product development and testing phase. And we also need mechanism to detect evasive developers, as we observed previously, like the developers can pass the test in evasive way. And finally, the user should be informed about the IoT product security certification, that is they should be and the certification lab and the IoT vendors should be more transparent about the certification. And thank you for attending my talk, and now I will be happy to take any question.